Hey, Vlad here, devinside.com. Welcome to another video. In the previous 3 videos, we talked about partial functions, pattern matching, and case classes. And today we're going to talk about error handling, with a big focus on exceptions, in which pattern matching plays a big role. Let's get started. As always, we're in the Ubuntu virtual machine, and we have Sublime on the left and the regular terminal on the right, which runs SBT, which runs our code every time we save the file. Since we're talking about error handling today, the first thing that I'm going to do is I'm actually going to create a new file with an object in there called helpers, and we're going to define a few methods that are going to just help me out explaining the concept. So I'm just going to say new file. I'm going to save it as helpers.scala. And it's going to be in the same folder as everything else, and it's just going to be a simple object called helpers. Let me remove the cursor, and it's going to have a private def called styled, right? And it takes in a string, and it also takes in a color. Let me press Ctrl KB like this, which is also a string, and it returns a unit. And all it's doing is print line color plus string plus console dot reset. We already played with colors before, right? And now we're going to have 3 functions: show red, which is going to take a string, produce a unit, equals styled string console dot red, and similar to that, we're going to have yellow and green. Oops, I pressed Control B instead of Control V. All right, so we're gonna have green with green over here, and we're also gonna have yellow. I wanted to spell it small. Hold up, yellow. There we go. So now in our main, we're just going to import helpers. And now we can play around with it. So instead of print line over here, we can say show red, and now I'm going to say also green, and also show yellow. And if everything works all right, we should see red, green, and yellow. And I'm even going to close the file because that's all we need. We're never going to touch it again today. We're going to start with a very simple example of writing files to disk. So let me create another file called file.scala. Again, everything is exactly in the same folder. And in fact, let me split the screen, and in the future, the file is just going to stay at the bottom. So like this, right? And over here, we're just going to have a class file. It's not a case class because it's not a data structure. It's going to be an object, but it has a few attributes: location, name, extension. Nothing spectacular so far. Content, right? And it's going to have one method. Right, we're not going to actually write anything to disk. We're just going to pretend like we are. So right, it's just going to print line a string interpolation. It's going to say writing content to location, and we're going to say dot dot dot, and we're going to pretend as if it takes a bit of time. So we're going to do this red sleep 1000. Right, and for now that's all we have with the file. So now we're just gonna go back to main. Let me make it a bit smaller because that's all the code we have. Over here, we're just gonna create a file. Right, I'm gonna say new file, and I'm gonna say location equals, and Sublime lets me copy the file path of the current file. So I'm just gonna paste it over here. I don't need it to be that long, so I'm just gonna start with like source. It's just an education example, right? So we're just gonna do this, maybe like this, okay? Now the name is going to be main, right? So now we can remove the name over here and the slash as well. Now we're gonna have the extension, which is .scala. So now we can also remove that, right? And we're going to have content, which is hello world, right? Like this, okay? And all we're going to do now is we're going to say file.write, hold up, like this. Let me scroll down a little bit. There we go. So it says writing hello world, and because we're sleeping for like one second, let me add a comment here, one second, then it takes a bit of time. So writing hello world, it takes a bit of time, and there we are. All right, so let's talk about error handling. So what if something goes wrong with the write? Right? For example, let's say we don't have permissions or we run out of disk space. The write basically doesn't happen. In this video, I'm gonna refer very often probably to the file class as a server code and to this as a client code. I will say things like, what if our clients, or what if our users, and things like this. Right, so in this case, we need to signal to our users somehow that the write failed. And we're gonna iterate through a bunch of solutions to that problem. And the first one is kind of simple. Well, instead of returning a unit, we're just gonna return a Boolean, right? So we're gonna return a Boolean, and let's say that in this example, you know, the write didn't fail, so it just succeeded. So let's just return true. So everything is fine, right? Let's see what happens if we return false. So we return false, and all of a sudden everything is still fine, right? So the thing that you need to know is that it doesn't matter which return type a method has, a client has always an option to not evaluate it at all, right? So the client doesn't have to do something like this, status, right? He doesn't have to do something like this. If status equals true, show green, life is good, otherwise show red, Houston, we've had a problem, right? So the client the server cannot force the client to evaluate the error code, and we're actually going to fight this problem in the end, and we're going to find a solution. And the second problem is that we also don't really know exactly what went wrong. In fact, by the way, let me switch it back to true so that we see that it actually works. So if it's true, then we see actually something green, life is good, okay? So again, the first problem is that the clients, there's no way to force or even to encourage the client to evaluate the status, right? And the second problem, as I already said, we don't really know what went wrong. As the next iteration, we're just going to use an integer as a so-called error code. So instead of just returning a Boolean, which can be true or false, we're going to return an integer. And the convention for this is to return a 0 if everything is all right, and to return something else if there was some error, right? So we're going to return an error code, and hopefully there will be a table somewhere where you can look up the error code, right? So now we just, if I save this, the code is not going to compile because it's not a Boolean anymore. Oh, actually it does compile because of the issues with equality, right? But we need to compare it basically with a 0. So if it's a 0, then life is good. Otherwise, something else happened. And what we can do now, like what we gain from this, is that we can also, somewhere in the middle, like over here, we can say else if, let's say, if the error code is somewhere between 1 and 99, right? If it contains status, and let's also rename status to error code, right? Then what we can do is we can say, well, you know, it's an arrow, but it's actually not so bad, right? Show yellow, right? And we're going to say string interpolation, warning, and we're just gonna show the error code, right? So if we return a 0, then life is good. If we return somewhere somewhere between 1 and 99, like 56, then we're gonna see a warning with the error code 56. And if it's 100 or greater than 100, then we know it was a big error. So we still didn't solve the first problem, right? So the clients are still not forced to evaluate the error code, and but at least now we know what goes wrong. We're not going to attempt to solve the first problem for quite a few iterations yet, right? But at least you know, we can still do some progress. So the next problem that we're faced with, you know, in this case we sort of got lucky, and we sort of, you know, just abuse the fact that we didn't have to evaluate the error code. But what if we actually do have to evaluate the result? Like, what if the, you know, we started with a result type of a unit, and then we switched to Boolean, and then we switched to an int. What if the result type initially was not even a unit? What if the result was, I don't know, let's say a number. Let's say it returned the size of the file. How are we going to solve that problem? Well, we learned about tuples, right? Or we could introduce our own type, but let's start with tuples. So we could say that it's not going to return just the error code. It's going to return, you know, the actual size and the error code, and we can encode it however we want. Let's say that the left value is the error code and the right value is the the actual size. Right, so if everything goes well, then the error code is going to be 0, right? And the second element to the tuple, which is the size, we're not doing anything serious over here. We're just going to do content.size. So we're just going to pretend like the length of the content is actually the size of the file. Okay, so let's save that and let's see what happens. All right, it still actually compiles, which is unfortunate, right? So let's actually modify our program a little bit before we just randomly fix the problem. Let's say that we initially had a variable called disk usage, and let's just set it to 10, and let's pretend that it's, I don't know, bytes, for example, right? So what we can now do is, so first of all, what is getting returned is not an error code. So what is being returned is a tuple, right? So tuple equals file right, and the error code is whatever is in the in the first element, right, like this, and the size is in the second one, right? So the rest of the code is still going to work because of the error code. And let's say in the end we're going to print out disk usage bytes, right? Let's make it out of here. So the idea is that if everything goes well, right? So if left is good, right? Then let's show green first, and then we can say disk usage, and we're just gonna increment it a little bit by the size that comes back, right? So if everything goes well, what's happening? Unclosed string literal. Oh yeah, there we go, like that. All right, so if everything goes well, right, so if the error code is 0, then life is good, and then the content size is 12, so it gets added to 10. I mean 12 because we have, where's our hello world? Because this is 12 characters, right? So the 10 gets added to 12, and we see the 22. And if something goes wrong, right, for example, let's say 54, right, then we're going to see the warning as we did before, and we see that the disk usage is not modified. The problem with this is that, first of all, the client doesn't really know which one is which, and if the left one is an integer, or if the left one is the error code, or if the right one is the error code, for example. And the second problem is that we're always forced to return the size, even if there was an error, right? So as of right now, we kind of don't see that this is a problem because we're not touching the size, but we could, right? So nothing prevents us from from touching the size, right? Nothing prevents us from always adding this to disk usage and not evaluating the error code. So ideally, what you would do is you would probably signal it as well somehow, right? So you would say, okay, so if there's an error, then I'm also not going to return the content size. I'm going to return something like -1 or something, right? But again, because our users can always call disk usage, for example, let's say that they always do this, right? Doesn't matter what the error code was. Let's introduce a bug like this, right? So in this case, we see that warning and error code is 54, but now the disk usage actually got less. So we're writing a file, and now all of a sudden the disk usage is less. So this is obviously a bug. Let me revert that real quick, like this. So now at least we don't have the bug. By the way, since we're we sort of talked about pattern matching in the previous videos, and there's still a few things that are left out. The cool thing about pattern matching is that patterns, they're not limited to the case clauses and partial functions. So patterns can appear in other places in the language. Specifically, every time you have a val or a var or a lazy val, then everything that is between the val and the equals symbol is actually a pattern. So this is not just a variable, and repeat after me, this is not just a variable, this is a pattern. In this case, it's the variable pattern. But what we could do is we could actually use a tuple pattern, for example, right? So we could do, so instead of these 3 lines, what we could do is we could say file.write, and now over here, instead of the variable pattern like this, we could pattern match. We could use, for example, the constructor pattern, and we could say error code and size. So this code right here is equivalent to this code over here. In fact, let me do this, and you will see that it works exactly the same. And we already know that for tuples, we can also use the special tuple pattern, right? So we don't have to use the constructor pattern. And let me actually prove the point to you that, prove it to you that it is actually pattern matching that is happening. every time you say val x equals 10, as I already said, this is not just a variable, this is a variable pattern. Let me show you what happens if you do val 10 equals 10. So you can create a variable called 10, right? But this code will compile, right? This code will compile. However, this code will not, right? Because we're just using a constant pattern on the left, and now it's going to say scala match arrow. It matched a 10 and not a 9. So this was just like a proof that actually what's happening behind this is pattern matching. In fact, let me show you another example, which is completely unrelated to error handling, which is probably, by the way, also the reason why my videos are getting so long. Let's say that you had a final class, just a simple data structure, final class, actually case class, because I just said it's a data structure, person, which has a name, and an age, which is an integer, right? Let's say you have an object, which is a person, database or person table in the database, has one simple method, get person. It gets some ID of the person, right, and returns a person. And in this case, we're not even going to run the code, so I'm just going to throw an exception over here, which is kind of ironic because this is the video about exceptions, right? So now let's say that we had a form, where we're building like a website. We have a person form, and there's a name on the form, and there's an age on the form, right? There's no person on the form, right? But it looks very, very similar to the person. And let's say that now we have an employee form, which is an object. It extends person form, right? And now we're forced to override those depths, right? What we can do is we can do override val. Now we can pattern match on the person, right? So we can do name, age equals, and now we call the person database get person with some ID 1337. So this will actually compile. So this will actually override these two depths. And as always, override in this case it's optional because these methods are abstract. And for clarity, for example, you could specify the types here, right? Because it's still a string and this is still integer, but technically it's unnecessary, which is kind of cool. All right, so I'm going to remove this whole example. It technically doesn't have anything to do with error handling. Let me scroll up like this, and let me also comment this out. So now our code is actually smaller and more beautiful. All right, so let's get back to our original example. We are in a statically enforced, strongly and safely typed language. There has to be a way that we can encode something like error handling in the type system, and therefore the compiler will force our users to evaluate the error code, right? So our users will never be able to forget to evaluate the error code. In the previous video, we learned about a type called option. And it seems like this value is optional, right? So it can fail. So instead of a tuple, we could just use an option of ints, right? Like this. So if everything goes well, then we just return the size as we did before, content.size, right? So file write is now returning an optional size, right? So this thing is an optional size now, right? And the actual size is going to be optional size dot get, right? And we also need the error code. In this case, we actually don't have the error code, which kind of sucks. But what we can do is we can say if optional size is defined, which is just a member on option, right? So we can't do this, unfortunately. So let me just comment this out, right? Let's see what happens now. Value get is not a member of int. Did I not save the file? There we go. Now I did save the file. Content.size. Oh yeah, we have to return an option. So we have to return a sum, right? Like this. So in this case, everything is fine, right? But let's return an error. So in the error case, we're just going to return a none. And let's see what's going to happen. And we see an exception, which is exactly not what we wanted. So the problem here is that, unfortunately, option has a way of retrieving the value even though it's a none, right? So this .get member, which Scala community notoriously hates. We're sort of all arguing that this should be removed from option, but it's not. So basically, we're sort of closing our eyes on this. And we've seen actually in the previous video why it actually has to have this member, right? So it has to have this member because of how pattern matching is set up. And if you don't know what I'm talking about, you might want to rewatch the video. So let's do the same thing as every experienced Scala developer is doing. Let's pretend that the .get actually does not exist. So all we need to do is we need to move the size over here, right? So only if the option is defined, only then we get it out, right? So now we actually get our behavior back. So we lost the error codes, right? So we don't actually know what went wrong, and we still didn't really, get type safety, right? Because we can call .get. By the way, let me teach you a few things about clean code. So it is always better to have a longer else clause, right? So in this case, we have an if clause, right, which is a few lines long, and we have an else clause which is tiny. It's always better to have the longer else clause because an else clause is optional. So if the if clause gets too long, let's say it's like 100 lines, then you would have to scroll down just to see if there is an else clause or not. Whereas the other way around, if the if was only 1 line long, then you would see right away, okay, there is an else or there is no else. Right, so there is an easy way to do this because an option doesn't only have the isDefine method, it also has the method isEmpty, right? So if it is empty, and now we just basically need to swap these, right? So if it's empty, then we show red, otherwise we do this. And now we have to be very careful, and we're not allowed to forget our curly braces, right? So we need curly braces if we have more than one expression over there, right? Let me actually remove this, it's just gonna disturb us. We don't need it over here. Right. So the thing is that now we have a different problem. The different problem is that it is also always better to have a positive case in the if clause. And if you wanted to solve that, all we need to do when there's a really, really simple trick is we're going to have a def, which is going to be called happy path. Right. So it gets a size in, return the unit, right? And the body is going to be this, show green, disk usage, size, like this, right? So this is the body, right? And because of that, all we need to do in the else clause now, we need to call happy path with the size, so we don't need to do this. And because it's getting kind of small, we can also do this, right? Happy path optional size.get. And now, because it's also 1 line, we can do this. Right, so now this code got much cleaner, and now you have 1 line in the if clause and you have 1 line in the else clause. So now you can bubble them however you want. So now you can have your cake and you can eat it too. So now you can use isDefined, right? IsDefined, and you can have the positive case over here, the negative case over here. They're both only 1 line long. You see right away that there is an else clause that belongs to this if. And since we're already talking about option, this is usually not the way how option is handled, right? Usually you would pattern match on an option. So usually you would say optional size match, and you would say case sum, which is the size. In this case, we call the happy path was the size. Otherwise, you can do case none, or you can just do case underscore, just show red, right? In this case, over here. So now you don't have to. Now there is no. I forgot how it's called. Cohesion, right? So now we have a better cohesion between the isDefine and .get because they're happening in one thing, right? So there's no way to forget one or the other. Otherwise, it's just not going to compile, right? So we can remove this, or actually just comment it out, and the result should be the same. So if it's none, we'll see the something red, and if it's sum content.size, then it's green, and it should be 22. All right, let's finally see a better, a rather type-safe solution. So instead of trying to use types that are already there, we're just going to create our own. So let me scroll up like this a bit. Actually, make it bigger and not scroll up. So what we're going to have here is we're going to have another object called write, and inside of it, we're going to have a sealed trait result. So we're building a simple algebraic data type, and the first form of creating it is going to be a case class success, which is just going to wrap the size, right? And it extends the result. The next one is going to be warning, which is a message string. So it just wraps the, the warning message, also extends the result. And the last one is going to be arrow, which is going to look exactly the same, right? So now, instead of returning an option of int, we're just going to return a right result, right? So we're calling right, so we want to, return a right result. So let's try to compile. Of course, it's not going to compile because we're still returning a sum. So let's say that in this case, everything went well. So we're just going to say success, right? I have to say right dot success, like this, right success. And now over here in the pattern match, over here it says, hey, you're trying to do something with an option, but you actually have a right result. So we're just going to do the same thing. So instead of the sum, we're just going to say right success, happy path. Otherwise, we can show red, right? Let's actually produce an arrow. So instead of returning a right success, we can say right dot arrow. Let's say permission denied or something like this. Let's say that we're not authorized to do this, right? So in this case, we're not going to see it, right? Because we're not pattern matching on it, but we could, right? So we could do now case right warning was a message. I prefer to spell it out. Now we can do show yellow message, right? And since we're already, I'm going to save it right away. We could also just duplicate the line and do the error and do show red was a message, like this. So now it seems like everything got better, right? So now we see, okay, permission denied. And if this was a warning, the warning could be something like not enough disk space. Please clean some stuff up, right? So now it's going to be yellow. We're still not running our happy path, right? We're only running our happy path if there are no errors, like this, right? Right success, everything is green, everything is fine. The user can't forget, the user knows exactly what went wrong. All right, it's time for a small discussion. Now, it seems like this is the final solution. It seems like it's perfect, right? So our user always knows what went wrong. Our user is forced to evaluate the exception, to evaluate the error code to see what's wrong. In fact, technically they're not. They could also swallow the exception. So the minimum code that they would need to write is something that we had in the beginning. So at least they can say if something went wrong, then we're just not going to do anything, right? So we're just going to swallow exception. The exception. Let me produce actually sorry, not the exception. It's called swallowing of the of the arrow, right? So we don't even see that the error happened. It's called swallowing or silencing, right? So this is also a problem. Let's say that we were a company and we're doing something with files, and we want to write a function. You give it a URL, it downloads the file, and then it writes the file to disk. Let's say that we had a lot of business logic and we had like a lot of layers of logic, right? So long before we got to that point, we already made sure that there is enough disk space and that the user's authorized, to, like, for example, if the user doesn't have access to, is not allowed to write to the disk, then probably he shouldn't even be on that, on that web page, on that interface, right? So we already made sure that that he has all the rights, that everything is fine, that he can write. If they decide to use our library, this one was a file and write, then at all the places where they're trying to write the files, they will be forced to write code like this. Like, this is the minimum of what they would need to write, right? And at the best, not at the best, like ideally, they should, do all of this, right? So this is, so 1, 2, 3, 4, 5 lines of code so that they would need to write. So this is this is an area for additional mistakes that can be made. This is additional code code debt, right? So let's say that they don't want this. Let's say that they are annoyed by this. I don't know, for some reason it doesn't rock their boat, and they want something else. They want something more convenient. This is the problem. Right now we have a very safe, very secure solution. Nothing can go wrong, right? But you always sort of pay for safety and security with the same price. You always pay with convenience. There are only a few things in this world where you get safety and security and you don't really pay for convenience, right? You don't really pay for it with convenience, right? So what are we going to do? Should we go back to those booleans and the tuples and so on? Well, no. And the answer is exceptions. exception is just a short name for an exceptional event, and they're sort of like the middle ground between this very, very type safe and very secure solution and, you know, the convenience of being able to discard the result, or not the result, the error code, right? And the way it works is very simple. Every method that you call, it can terminate, basically it can finish what it's doing in two ways. It can finish it in the normal way by returning what is specified by a signature, or it can throw a so-called exception and thus terminate in an abnormal way. And exceptions are regular classes. You create instances of them and you can throw them. There's a special keyword called throw in the language, and this is how it looks like. So you can create a simple object of type, in this case exception, by just saying new exception. And now what you can do is you can throw it. You can throw E. In fact, there's a big joke about this. You can call it up, and now you can throw up. Kind of fun. Right, so throw E. Right, so now what is happening is that you see Java line exception, blah, 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 and we're going to discuss all of this a bit later. But what you see is basically that this function, right, it did not return a right result. So it did not even get here, right? So it can be also somewhere in the middle of the code, somewhere like over here, right? Whoops. So now it's going to print this out, and then it's going to explode, right? So we see this, and then it exploded, right? So it's taken completely out of the normal flow of control. And by the way, we discussed this already before. When an exception is created, then its type is, in this case, exception. But when it actually gets thrown, right, this thing, we can add a type description, and it has the return type of nothing, like this. Right, so the code's still compiled, but, you know, the effect is still the same. Again, notice that the entire flow of control, so the entire flow of this method, and therefore the entire flow of this entire program, I just said entire like 3 or 4 times. Anyway, that it's interrupted, right? It completely stops, so to say. And we're going to talk about this more in just a few minutes. But let me already say one thing, that just the fact of having exceptions is a privilege of not being so close to the hardware, right? So we're not in C or, you know, C++. We're actually running on top of something. So we're running on top of the JVM, the Java Virtual Machine, which is also known as the, you know, the runtime environment, right? And it makes sure that whatever code we put into it, that it's not gonna, you know, corrupt our memory. So we're never gonna like end up somewhere in the middle of invalid memory, that it's not gonna, you know, ruin our hardware, you know, ruin our computer, right? So it's a privilege. It's a good thing that they are in the language. They give you more options, you know, which is also a trade-off. So it's not always good. Now, before we continue, let me say 2 things. First of all, exceptions are kind of frowned in the Scala community. We love our code to be type safe. In fact, Lightband, the company that is officially supporting Scala, used to be called type safe. So we, the Scala community, we love to make the compiler, not make the compiler, well, to let the compiler do as much as possible for us, to do as much work as possible for us. Funnily though, we also love to complain about how slow it is, which is kind of funny. On a rather serious note though, if you're coming from Java, for example, and you have the feeling that the Scala compiler is slower, it is actually not. It is actually way faster, because there is so much effort being invested into making it faster. The problem is that it feels slower because it just has so much more to do. If you don't believe me, watch my previous video about case classes and see what the difference is between the code you write and the code that the compiler actually generates for you. It's shocking. And number 2, even though Scala was invented with a very strong type system in mind, it is always a trade-off, right? It was chosen to be a bit closer to Java, to make it more friendly for Java developers to learn Scala. Therefore, exceptions do exist in the language, and therefore every time you see a method signature like this one, which says, hey, I'm going to return the right.result, it is always implied that an exception can be thrown. Always. There are no exceptions. Yes, pun intended. So eyes on the ball, people. Eyes on the ball. All right, so what can we throw? Let's try to throw a 10. Let's try to throw a 10 like this. Right? It's going to say found in 10 required a throwable. Throwable is just a simple trait which is on top of, in this case, exceptions, right? So in fact, we can change this to throwable, right? And now we can throw E, and it's still going to throw, right? Same effect. All right, so first of all, let me actually remove these 2 lines. That was just a demonstration. Okay, so how are we gonna make use of it? So we still want to return a right result, right? But if we wanted to throw something, then we need to make our return types throwable, right? So in case our warning and our arrow, these are throwables, right? So we can try with throwable, which should not work because if I'm correct, then throwable is a class, right? So we're gonna do instead, we're gonna say extends throwable with result. Let me actually make some my sublime so that you see the whole code, right? So it says throwable with result like this. Copy that, go here, and replace all of this, right? So now it extends throwable. By the way, this is also a very good reason to have it as a trait, right? Because if we had an abstract class here, we wouldn't be able to do this. You can only mix in the traits, right? Let me minimize it again. Okay, in fact, maybe I should do this. Let's say extends throwable with result like this. Let me have some spaces over here. Because I kind of want you to always see the code. There's also an option to set up my editor in such a way that it wraps the line so that the line appears wrapped, but it's actually not wrapped. But I really can't get used to it, so I'm always gonna wrap my lines manually. The next thing that we're gonna do, we're going to rename this function to safe_write. Safe_write, and now we're gonna fix it over here because it's not called safe_write. And what I'm gonna do is I'm gonna copy it. I'm going to copy it like this, and now I'm going to have a function called convenient write. Okay, and the convenient write, it will just return an integer, right? So the idea is that if everything goes well, then we just return content size, like similar to what we have over here, content dot size. And a bit later, we're going to use, something like this, right? So we're just returning content.size, and now we can go back to our code and actually call it. So we're going to do convenient write, and now we're sort of, we're sort of back to the code that we had before, right? So we can do, we can just do happy path with the size, and I probably should put happy path a bit higher, like this. Let's have it, let's have it like that. Right, so optional size, file convenient write, happy path.size, and we're not going to do this for now. In fact, we still have some old code there. Let's remove it like this. Okay, so we have our disk usage, we have our happy path, we get the size from the convenient write, we're just calling happy path, and then at the bottom we also do this. Let me put it up. Yeah, so now we see the whole code. This is all we need, right? So we do convenient write, and what's happening? Oh, it's called optional size. In fact, in this case, it's not an optional size anymore. It's called size, right? So we're just getting the size, right? So basically ignoring all the errors as before, right? So if there was an error, let's actually try to produce an error, right? So we can do right.warning. Let me remove that. Let's see what's going to happen. Now it's not going to compile, right? Because in the past, like this thing, it compiled because we're returning a right result. In this case, we're returning an int, right? Because we don't have to specify what is being returned in the abnormal case, right? So instead of returning RightWarning, we need to throw RightWarning. So let's throw it and let's see what's going to happen. So now, since we're ignoring the arrow, we actually see this exception being thrown and not handled. We're going to talk about handling in a few minutes, right? Let me also show you what's happening if we actually throw before. If we try to throw before, now it's not going to compile because the result of thread.sleep 1000 is a unit, but we're forced to return an integer, right? So we're forced to return any number, even though it's never going to be evaluated, right? So this number, which is too large for an integer, is never going to be evaluated, because the exception is going to be thrown, but the type system still forces us to return an integer. And by the way, I was kind of hoping that the Scala compiler, actually, let me see. Let me clean and let me compile once. Right? I was kind of hoping that the Scala compiler would warn us that this is unreachable code, right? Because it should kind of see that we're throwing an exception, but it doesn't. So it's something to be aware of. Let's move it back down like this. So we're throwing the warning, throwing the exception, which is defined over here. It extends throwable with the result, and we're not handling it. Now we're going to talk about handling exceptions in just a few minutes. For now, let's actually see exactly what's happening. Like, what does it mean that the exception is being thrown? What does it mean that the flow of control is interrupted? So what we see here, so we see our write, right? So we see this print line. We see writing hello world to source main Scala, and then we see an arrow. Then we see run main 40, which is the name of this thread. We haven't talked about threads too much, but remember in the video about recursion, we said that, I said all you need to know about a thread is that it's the thing that runs methods. So it puts them on the stack. You create those stack frames, right? So what you see here is actually a stack trace, and we're going to talk about it in a second. The first thing we see is the toString of the warning in this case. So if the toString of our case class. Usually the toString of a case class doesn't look like this. I believe that it's happening because there is a method called toString already defined in a throwable, and because it's defined, the case class does not, it's not enough to convince the compiler to generate a toString method because it's already defined. So what we can do is we can just override it ourselves. So we can go here and we're just going to say override def toString, which is probably something you should do every time you extend throwable. This is going to be a string interpolation over here. And because it's a case class, we can just use product prefix, which in this case is just warning. If you don't know where this is coming from, maybe you should watch my previous video about case classes. So we're going to just make it look like exactly like case class toString methods look like. So let's see if it compiles, and if it does, then we're going to do the same thing over here. Right, so it actually compiles, and now we see this in the stack trace. So we see the name of the thread in parentheses, and then we see warning, not enough disk space, please clean some stuff up, right? Which is kind of cool. All right, so let's go through this entire stack trace. Let me maximize the terminal. So the first thing that we see is that our application died. So this happened because the exception was thrown in the main thread, and there was only one thread, the main thread. And if the main thread dies, right, so then the whole application dies, and the main thread dies because the exception was not handled anywhere, right? We didn't talk about handling exceptions yet, right? So what you see here is at the bottom it says non-zero exit code, which is funny because it's like a convention. Every program that finishes, it returns an exit code, right? It's like an error code, and the convention is the same. So if it's 0, then everything went fine. If it's a 1, that it says it's a non-zero error code, which means it's a not normal error code. So the application finished abnormally. So what we see over here is we see the stack trace. So we see a representation of the method call, right? So at file.convenientWrite, which is in the file called file.scala on the line 19. Let me minimize the terminal again. So if we go to file, line 19, we actually see throw RightWarning, right? So this is exactly where it happened. And where was it called from? It was called from code in main Scala 28. So let's go to main Scala 28 over here. File convenient write. So file convenient write was called from main code in Scala 28. So it just keeps going like this. Let me maximize it again. It keeps going like this until some native method calls here. It's a native method. So it's a method called on the JVM, and then you see stack trace suppressed, run last compile run for the full output, and then we see non-zero exit code 1, and then we see another stack trace, right? And basically what's happening is that SPT actually handles that error, and then it wraps it in another exception, which we're going to talk about in just a few minutes, and this is why we see both. So let's first press enter and type in last compile run. In fact, maybe I can copy it, right click paste, enter. So now we're actually seeing the full stack trace. So we're seeing over here the same as before, but a bit longer. We see our actually we see something else. We're saying, okay, we see some debug messages from SPT. That shouldn't really matter. Then we see the same as before, right? Just a bit longer. And then we see some debug messages. So it says the thread run main exited, right? So the number 42 is because we're probably running it for the 42nd time. In fact, let's run it again. Yeah, so see now it says run main 43, so it's because we're running for the 43rd time, right? So now it says, okay, the thread died. It says interrupting remaining threads should be all daemons. I think daemons means that daemons, I believe, are the threads with a certain property that they don't die when the application dies or something like this. I don't remember exactly. Doesn't matter. This video is not about threads. It's not about concurrent execution, right? So then it says sandbox run complete. So SBT sandboxes the JVM, so the JVM dies, but the SBT does not. What was then sees Java long runtime exception. So this is specific, I believe, to SBT. So what it's doing is it catches the exception, it rethrows it, and we see the stack trace of the runtime exception now. So we see Scala sys package error, some functions called apply, and so on and so on and so on. So that's all we need to know, I think, about the stack trace. And by the way, every time you follow the stack trace, so I'm using Sublime, which is a regular editor, and we're gonna have videos about integrated development environments later. Even Sublime, it allows you to jump to methods, right? So for example, in our let's run it again, right? And it says, okay, file convenient write. So, and then it says main code, main scala 28. So if you look at this, if we're over here, then I can put my cursor over here and I can jump into this method. Unfortunately, the default key binding is F12 and I have F12 for something else. If I press F12, a terminal comes up. So what I can do is in Sublime, I can press Ctrl+B, I can type in settings, I can maximize Sublime. Oh, actually, I don't need the settings, I need the key bindings. So if I do the same thing and I type in key bindings, on the left I see all my key bindings, and I can look for, by default it should be F12. So it's command go to definition. So what I can do is I can just copy that and paste it over here, remove the comma, and now over here instead of F12 I can use Ctrl+B, which is the same combination that IntelliJ is using, which is an integrated development environment, right? So now I can click on it here, I can press Ctrl+B, and it's actually going to jump to the convenient write. In this case, it jumped to the oh no, it did jump to the correct one. The problem is that I was hoping that it would jump like in a different tab, but it didn't. It just opened the file again. Let's close it. All right, so now we know enough about exceptions. Let's see how we actually handle them. The first thing that we need to do is we need to tell the compiler that we want to handle them, right? And for that, before we do that, we just need to do a small refactoring. So I'm gonna do a save call over here. It's gonna return an integer, right? And the first thing that it's gonna do is it's just gonna return the file convenient write for us. And now we're gonna use the save call over here. So as of right now, it was just a refactoring, so the code has exactly the same semantics, right? So it still throws an exception. So if you wanted to tell the compiler that we wanted to handle the exception, you need to start with a keyword called try, like this, try. And there's also another keyword called catch, which we're going to discuss in just a few seconds. And try catch is a simple control structure, like if else, for example. So you can use it with any expression, and when I mean with any expression, I mean every time you say, for example, val x equals 10, you can also do val x equals try 10, which is not going to do you any good, but at least you can, right? So let's see what is actually happening. Let me save the file real quick. So what we see here is we don't see the warning again. So what happened before was that we were seeing a warning. It was a compilation warning. And the thing about SBT that you need to know is that it has a thing called incremental compilation. So it only recompiles the things that changed since the last compilation, right? And in this case, nothing changed, right? So let me actually stop it. Let me do clean. Let me do run again. In this case, it has to compile again, and this is why it goes through the compile phase and it gives us this warning. And it says a try without a catch or finally is equivalent to putting its body in a block. No exceptions are handled, right? So this is not enough. So, and by the way, as always, if we have multiple expressions here, we need to use curly braces, right? As always, as in the very first video, right? So what we need to do is we need to have a catch. And in the catch, we need to give it a partial function. And we're going to define it over here. Val pf equals partial function. We already talked about them a few videos ago, right? And it has to have the type throwable to, in this case, int, right? So if you wanted to give a partial function to catch, it has to start with a throwable. or a subtype of throwable. And in this case, you know, it can return anything we want, but in this case, we have to return an integer, right? So if we have a partial function like this, I'm not going to do anything over here. I just want to show you that it still compiles, right? And now it throws another exception, says an implementation is missing. So remember, I told you that this triple question mark is just a method defined in somewhere in Scala, and all it's doing is it's throwing it throws the not implemented arrow, and with the message an implementation is missing, right? So we need to add an implementation, and all we need to do here is we need to say case E, right, which is, you know, stands for exception usually. And on the right hand side, we're just going to do, let me do it in one line actually. We're going to show red E dot to a string. So what we're seeing here is found unit required int. So the idea is that this try catch control structure, it interrupts the abnormal control flow and restores in the normal control flow. And in the normal control flow, the compiler wants you to return an integer, right? So we have to return an integer. So basically, we catch the exception, we handle it by returning a default value. In this case, the default value is going to be -1, right? So now it's going to work. So now the exception is showing. We're showing, you know, we're showing the exception. So now it's warning, not enough disk space. Please clean some stuff up. We're showing it in red, right? And that's all. So we have a try and we have a catch, and it accepts the partial function. And because the catch accepts a very specific partial function, then we don't have to explicitly, you know, say the type here and declare it like completely separately. What is common and basically always used is that you inline it. So let me copy that, just put it over here, right? It's not properly formatted. It should be like this. Now we don't need the partial function, right? Now, what we should see is a warning. It says this catches all throwables. If this is really intended, use case E throwable to clear this warning. Well, I mean, for sure we can clear this warning, right? But we shouldn't. So the thing is that throwable is just a trait, right? It's just an interface in Java, actually. And there are two implementations of it. One is exceptions, which is something that can be handled by our code, by the programmer, right? And there is another implementation of throwable called arrow. And the idea is that those errors they should not be handled by the programmer. Those are errors like running out of memory, running out of RAM, or running out of stack trace, right? So the stack overflow exception. Remember the exceptions that we were getting from the videos about recursion, right? So the idea is that there is no need to handle them because you can't do much about them anyway, right? So the very least that you should catch are exceptions and not throwables, right? So the very least should be exception. It's always better to pattern match exactly on the exception that you have. But unfortunately, you know, most of the time what you see is case exception, because most of the time you can't do much about it. Usually you just log the exception, right? So what we can do now is we can basically move back to the code that we had before, right? To the code in this pattern match, right? So we can take these ones, for example, right? We can take them, we can put them over here, right? Like this. So we can say case warning, say case error, right? Like that. And the last case is still going to be, you know, something else, right? Some other exception. So this is a type pattern, and this is the constructor pattern, because our exceptions, you know, they happen to be case classes. And we always have to return the -1, right? So whatever happens, we have to return the -1. We have to return an integer. We're forced to return an integer, right? So now it says life is good because it's just a warning. No, hold on, that's weird. Why does it say life is good? Oh yeah, because we're still always calling the happy path, right? That's not what we should do. What we should do is over here we should refactor our code a little bit and only call happy path in this case, right? So only in this case, so this is going to be the size, right? So we're safe to call the happy path. Let me move it up like this. And now, because the happy path returns a unit, the whole expression can return a unit. Now we don't have to do those silly -1s over here, right? So we can remove all of these, right? And we can remove this, right? So now only if everything goes well, you know, we see the happy path. That's actually kind of silly. We should see the warning, but we're not seeing the warning because we're actually not calling the save call. In fact, now we can just remove it. We don't really need it. In fact, let me leave it just for now. Let's just call it over here, save call. So our program basically calls, it does save call, and then does this, right? So now we're going to see the warning, and we're not going to call, you know, the happy path, but if we return an actual size like this instead of this, right, so we're not throwing it, we're just returning, then we see life is good. And also if we return an arrow instead of warning arrow, let's just keep the message the same, right, then we're going to see the arrow. There's also a way to always run some code after either of these paths are going to finish, right? So it doesn't matter if this one was running or this one was running, we can always add some code. We can always say finally print line finally, like this. So you might be wondering, why do we even need finally, right? Because over here, the flow of control is restored anyway, right? So we could just, you know, just print out finally, and it's still gonna run, right? It doesn't matter if it was the exception or if it was the normal control flow, right? We still see finally. So why would you need the print line? Well, the thing is that it's very common for exceptions to be rethrown, right? So in this case, for example, where we're throwing an arrow, it's very common to catch the arrow, you know, to log it, and then to throw it again, right? To throw, we would need to bind it to a variable like this, e at, right? And now we're just gonna throw e, right? And now the thing is that we don't see the finally, right? So this print line finally, we don't see it, right? So with and finally keyword, we actually would see it, right? And the rules are always the same, right? So we see finally here, the rules are always the same. So if you have more than one expression, then, you know, you would have this, right? So finally, it's just something that should return a unit, right? Like this. Okay, so by now we're done with the basics. Let's have a small discussion, and then we're going to go through a few details and through a few other things that you can do with exception. Okay, so number one is that exceptions are very useful, but only because they're convenient. Like, this is sort of like their only strength. For example, this is why when you divide 1 by 0, the return type is not an option of int or some custom return type. It's just going to throw an exception, right? So the return type is a regular int, because 99.999% of the time, you know, the result is going to be the exception is not going to be thrown, because probably, you know, you would have checked for 0 somewhere before, right? Way before. Number two, exceptions are there for exceptional behavior, right? So you generally, you know, when you catch them, first of all, you don't expect them to happen, and, you know, it's kind of weird to expect exceptions to happen. They're exceptional, right? So when they happen, you actually can't do that much to handle them. Like, usually when you do it properly, all you can do is you can log them. You know, it is advised to always, you know, pattern match specifically on the subclass of exception that you care about and handle it perfectly. But in reality, most of the time you will see something like this, case e exception, and then you just log it. I'm not saying you should do it. I'm just saying that if you make something so convenient, then don't be surprised if everyone's going to use it. Number three, and this one is very, very important. There's a huge difference between arrow handling and validation, right? So for example, if you imagine a user form, for example, right, and the user fills it out, it is sort of expected that, you know, they might put some garbage in instead of an actual phone number, right? So in this case, it is not an exceptional behavior, it is expected. Therefore, it is validation. So there has to be some code that validates the entire form before it goes through the rest of the business logic and before it goes to the database, right? So it has to be validated. Exceptions are sort of happening, you know, in the back, right? So after the thing happened, right? So you call something and then it explodes, right? So therefore, you always have to evaluate your use case and to understand, are you expecting things to go sideways or not? And if you are expecting this, then please, especially in a strongly statically typed language like Scala, please expose this in the public API. Expose this in the signature of the method. Make sure that the method returns at least an option of the value that you're expecting, or even better, you know, write your own type. Also, exceptions are a bit less performant than, you know, the normal code flow. So exceptions should never be used for controlling the normal flow, right? Let me give you another example. For instance, let's say that you're a local company And at some point you're deciding to go international, right? So you go you look at in your database, and you look at the table or the collection, depends on what database you're using. You look at the representation of the user, right? And you understand that all of a sudden the user needs to have a country because your local company goes international. Now you have to evaluate your use case, and you have to understand, does the user need the country, or is the country conceptually an optional thing, right? It is not a technical decision. What happens in reality usually is that developers are trying to be too smart, and they're trying to take too much responsibility, and they're making this decision for the business because they in their mind it is a technical decision, but it's not. You simply should not make this decision. You should go to a business, and you should ask questions like, okay, what is going to happen if the user did not fill out the country field? Like, should it be possible? Is it required? If he's not going to fill it out, what should be the default country? So you have to basically realize that if the field is mandatory, then what you need to do is you need to run through your entire database, and you need to run a migration, right, by filling out this extra field by probably the country that you were originally in. But if this field is optional, you need to do the opposite. You don't have to go through the database, you have to go through your entire code base, and you need to change the signature of those methods, right? So the method that gives you the country, it probably doesn't even exist because your company was local before, but the method that you're going to write that returns you the country, it should now return at least an option of case class country, right? Or even better, your own result type. So please every time evaluate your use case. Also, knowing the domain is not enough. You need to know your use case. You need to talk to your business people. They rely on your expertise, right? It's your responsibility to know that you have to ask them these questions because they don't.